Very good evening, students. Today we are going to see regression analysis techniques for modeling relationship between process variables. In chemical engineering, numerous processes involve multiple interacting variables. Regression analysis is a statistical technique used to develop mathematical models that describe the relationship between the variables. Let's say we have dependent variable and independent variable. What is the independent variable? Like temperature, pressure. Okay. So the dependent variable is a, let's say, is a yield of a reactor. Okay. So when the temperature and pressure varies, that is what do you call the independent variables, the dependent variable will changes. So how it has been correlated, that's what we are going to do in the regression analysis. Okay, whether it is in which way it is fitted. Okay, the data has been fitted, whether it is a linear or non-linear or polynomial and so on and so forth. Okay, so the regression analysis is a statistical technique. It helps engineers predict outcomes, optimize processes and understand how changes in input variables affect the output variables. Regression analysis is a statistical technique used to model the relationship between the dependent and the independent variables. So the independent variables like temperature, pressure, concentration, dependent is, let's say, is a reactor yield. Okay. It helps in predicting the outcomes, understanding the trends and making data driven decisions. In a simple form, regression aims to answer how does one variable change when another variable changes. Can we use the past data to predict the future values? Obviously, this regression analysis will help us to do so. Okay. So what is the significance of regression analysis? So I just give you on 5 important significance: prediction and forecasting, process optimization, identifying the key influencing factors, decision making and policy formulation, understanding the relationship between the variables. So I have given this for these 5 significant important points in a general perspective, not in terms of chemical engineering perspective. We will see one by one. Regression is widely used in science, engineering, business and even economics and medicine. So first one, the important significance is prediction and forecasting. Regression allows us to predict future values based on the historical data. So estimating the temperature change based on the environmental factors. Let's imagine when you have a polluted area. Okay, let's say people have been talking about global warming, higher carbon footprint and fugitive dust emission in a particular area, industrial area. So because of that, what will happen? The sun rays which is coming from the sunlight will get absorbed and then reflected back to the earth's surface itself, so that we will feel very warm. So estimating the temperature changes based on the environmental factors. So it's a example for prediction and forecasting. So the second one is process optimization. In engineering and industry, regression helps optimize the process by analyzing how variables interact. So maximizing the chemical yield by adjusting the temperature and pressure. Just now I told, right? So the chemical yield by adjusting the temperature and pressure. So is a process optimization. The temperature and pressure is a dependent or independent variable. Is an independent variable. The dependent variable is chemical yield. Dependent on temperature and pressure. Dependent variable depends on the independent variable. Okay. So identify the key influencing factors. Regression helps determine which factors significantly impact on outcome. In healthcare, finding which factors, for example diet, exercise or genetic problem, which will increase the cholesterol level. So the cholesterol level is a dependent variable. So it may be a genetic reason, okay, is a independent, and this two, the patient does not do, I mean if the patient or the people who does not do exercise, obviously their cholesterol level will increase. Improper diet, that is again increase the cholesterol level. Okay. So decision making and policy formulation, this is one of the significance. Regression based models are used for making informed decision in finance, business and government policies. estimating the inflation rate based on the economic indicators. Okay, so this is one of the example for significance for decision making and policy formulation. Okay, and understanding the relationship between the variables. Okay, let's say the regression helps quantify the cause and effect relationship, how fuel consumption changes with speed in automobiles. When you go higher very fast, obviously the fuel consumption will be more. So in the speedometer you could be able to look into the indicator, which is a green indicator, yellow indicator and red indicator. When you go for red indicator, it not only shows that alarm for that you are going speed, but also the energy efficiency of fuel consumption, it will be more, so it is not optimized level. Okay, so you should understand the importance of this regression analysis. So these are the 5 significance of regression analysis. And coming to the regression analysis techniques for modeling relationships. Okay, regression is a powerful tool for modeling, prediction and decision making. By understanding the relationship between the variables, regression helps in improving the process, optimizing the efficiency and making informed predictions across various industries. So it is a powerful tool for modeling, prediction and decision making. Okay, coming to the different types of regression analysis. One is linear regression, multiple linear regression, non-linear regression, polynomial regression, and another 3 types is logistic regression, ridge and lasso regression, partial least square regression. Coming to the linear regression, you see the models relationship between the dependent and independent variables using a straight line equation. Y is equal to a plus bx plus epsilon. Y is a dependent variable. So y depending on what? X. X is a independent variable where a and b are coefficients. So here the dependent variable is directly proportional, is a linear relationship. Okay, x is a independent variable, is a linear relationship with the x. That means dependent variable is a linear relationship with x independent variable. A and b are coefficients and epsilon is the error term. What is multiple linear regression? If you see the dependent variable have independent variable multiple times, it's a multiple independent variables, meaning to say you have not only one independent variable, you have multiple independent variable, x1, x2, x3 and x4 and xn up to xn. Okay, so the multiple linear regression is nothing but you have a dependent variable depends on multiple independent variables, not only one or two or maybe more than one. Okay, so multiple independent variables. Coming to the non-linear regression, models non-linear relationships where the equation may involve exponential, logarithmic or polynomial terms. So for example, exponential growth rate, okay, or log means. Okay, we will say the temperature difference, log mean temperature difference, log mean pressure difference. Okay, because it has been increased logarithmically, right? 10 power. Okay, log to the base 10. Okay, natural logarithm is a exponential. If you take a e power, that is a 2 point times. Okay, so exponential times. Okay, 2.7, that value you know already, right? So the polynomial regression fits a polynomial equation to capture the curvature. Let's say the dependent variable, okay, y is dependent on x square plus x cube is a power. Okay, so x is a independent variable, x square is a second order, x3 is a third order. So if you see the dependent variable fits on the polynomial equation. Okay, so so there are another 3 types of logistic regression, ridge and lasso regression, partial least square regression. When you see logistic regression used when the dependent variable is categorical, for example pass or fail. Okay, ridge and lasso regression, regularization techniques to handle multicollinearity. What is multicollinearity? Okay, multicollinearity occurs when 2 or more independent variables in a regression model are highly correlated with each other, so that you could not be able to find the effect of individual variable on the dependent variable. So it makes difficult to determine the individual effect of each variable on the dependent variable. So that's why that's called multicollinearity. Okay, so when you see this type of problem arises, okay, let's say the temperature and pressure, the temperature is directly proportional to pressure, PV is equal to nRT. So when this varies, the yield, the temperature and pressure is already have a correlation, okay, highly correlated. So we could not able to find the effect of individual effect of pressure on the yield or individual effect of the temperature on the yield, because this itself is correlated each other. Okay, so the individual effect is very difficult to identify, okay, on the dependent variable. Individual effect of independent variable on the dependent variable. Okay, hope you got it. Partial least square regression, useful when the independent variables are highly correlated, such as multi-component chemical process. So when we need to go for partial least square is highly correlated. Okay, underline the word highly correlated. So we will see an example with these three types of again regression analysis elaborately with an example. Logistic regression, for example, in a pharmaceutical plant, tablets are classified as acceptable or defective. So is a yes or no, 0 to 1, 0 or 1. Okay, it's like in coding we use binary digits, right? 0 and 1. Similarly like that. For example, in a tablet manufacturing, compression force is important, humidity level is important, and raw material particle size is very important in order to obtain a product which is having an acceptable range. Otherwise, it is considered to be defective. For example, compression force. If the compression is not proper, what will happen? The tablet is not tightly packed. Obviously, it may get loose packed. When the patient want to take, it will be like in a stickiness, I mean a powder form. So the compression force should be exactly correct, need to be applied in order to while manufacturing the tablet. Humidity level. If the humidity level is very high, what will happen? It will have a tendency, it will absorb the moisture which is present in the atmosphere, air, right? So that will lead to a stickiness. So if the people having a stickiness tablet, they could not swallow as such, right? It is very difficult to swallow and it may stick on the thing, because all these tablets material is made up of bioactive material, okay, which will help you to diagnose the diseases. So the reason for taking a tablet is actually to diagnose the problem, health issues, right? So the raw material particle size. So if the particle size is agglomerated or is not proper, obviously the processing will be difficult. Okay, so these are the characteristics which will affect the final output, that is we need to accept or not acceptable. Okay, so using logistical regression, a model can predict the probability of a tablet being pass or fail based on these parameters. And coming to the Ridge and Lasso regression, the catalytic reactor efficiency depends on temperature, pressure, reactant concentration and feed flow rate. Okay, they mentioned TTT just for example. Okay, just consider it is only T, P and C and F. Okay, so it's a typographical error, just leave it. Okay, since these variables may be highly correlated, Ridge regression helps prevent overfitting while keeping all variables in the model. So there is a two thing, Ridge regression and Lasso regression. Lasso regression will eliminate the unimportant variables, leading to a simpler model, whichever is having a more effect on the dependent variable. Whichever is an independent variable which is having a less effect on the dependent variable, that can be taken out in the case of Lasso regression. Hope you understood what I am trying to say. Okay, so coming to the partial least square regression, a very good example, spectroscopic techniques like FTIR, Fourier transform infrared spectroscopy, NAR, numerical infrared spectroscopy, okay, infrared spectroscopy, and measures absorbance at different wavelength, even UV spectrophotometer, which will help you to determine the elemental analysis, right? Elements, calcium, magnesium, things like that. Okay, so the spectroscopic techniques measure absorbance at different wavelength to determine the component concentration. Okay, so in that case, these are highly correlated. These spectral measures are highly correlated with the concentration of the final output. So in that case, we need to go for a partial least square regression. It is used to extract the meaningful relationship between the absorption spectra and component concentration, ensuring accurate chemical composition and predictions. Coming to the chemical engineering application of regression analysis, this is very important. When this regression, what are the cases? I just try to give you 3 examples. One is a heat exchanger, modeling a heat exchanger. For example, I just would like to model the shell and tube heat exchanger is used to heat a process fluid. Okay, so the outlet temperature is depend on there are several variables such as input temperature, mass flow rate, heat transfer coefficient. Okay, the outlet temperature is not only depend on one variable, is depend on the multiple variable. So A plus B1 T in plus B2 M plus B3 U, where you could able to see here there are different input what you call them independent variables, that is inlet temperature Tn, mass flow rate M, heat transfer coefficient U, and epsilon is error, and the B1, B2, B3 are coefficients. So using multiple regression analysis between these variables can be modeled as such as given in the equation. The regression model can help predict the outlet temperature of a different operating condition and optimize the heat exchanger efficiency. Coming to the second model, that is a example. Okay, sorry, second example, kinetic modeling of a chemical reactor using non-linear regression. Let's say R is equal to, okay, here the equal to sign is a lightly, I mean it's not a equal, I mean it's a hidden. Okay, so R is equal to is a reaction rate A e power e minus a by RT, Arrhenius law, and C into W, Arrhenius equation. Okay, it also depends on the, okay, C and W. What is C? Is a reactant concentration and the catalyst loading, where N and M are constants. Okay, so when you see here using a non-linear, so exponential increase, the rate of reaction depends on the exponential activation energy, rate constant, temperature, C is the reactant concentration, W is the catalyst loading. Okay, so this is a non-linear regression because it's a non-linear relationship. Okay, so determine for this non-linear model helps determine the reaction kinetics, optimize the reaction condition. If you once you know the rate equation, R is equal to K into Ca power N. Okay, reaction kinetics can be determined, optimize the reaction condition, improve the catalyst efficiency. Okay, so hope you understood in chemical engineering perspective how this analysis, regression analysis will help you. Okay, and coming to the third part of the example, here is a distillation column. This is we are going to obtain a polynomial regression. Let's say distillation column, the separation efficiency depends on reflux ratio, feed composition, boil up rate. So when you see here, R is the reflux ratio, XF is the feed composition, V is the boil up rate. Similarly, it has been increased to R square, XF square, and V square. So is a power, it is increased polynomial. So it's a second order, third order, and it will go and so on and so forth. But here they have given only the second order. Okay, so the efficiency depends on the first order as well as second order. It's a polynomial regression. This model can be used to optimize the distillation parameters, improve energy efficiency, enhance separation performance. Okay, coming to the understanding of regression analysis, it is used, is an essential tool, is a statistical tool in chemical engineering for predicting the process outcome, optimizing the performance, and improving the efficiency. Different regression techniques like linear, non-linear, polynomial, logistic, partial least square regression, okay, these are all available, okay, which with an example we have already seen are used depending on the complexity of the process. When we need to go for the thing, depending on the complexity, we need to use it. Obviously, because of the system, we could be able to see the relationship. Once the relationship has been found, whether it is a linear or non-linear, between the dependent and independent variables, obviously we could know actually which linear regression analysis is coming under. Okay, so with this note, I would like to conclude today's section. So what we have seen in today's class is the example for regression analysis, different types of regression analysis, and the significance of regression analysis. Okay, with this note, I would like to conclude the section. We will see in next class shortly.